Problems in fluids, 3. Problem 4. A certain object weighs 315 newtons in air. When tied to a thread to a balance and immersed in water, it weighs 265 newtons. When it is immersed in oil, it weighs 269 newtons. Find A, the density of the object, and B, the density of the oil. First of all, 315 newtons is the weight outside. Let's put it in water first of all, and we see that the weight here is going to be 265 newtons. So let's calculate the buoyant force when it's in water. That will be 315 newtons minus 265 newtons, and that will be 50 newtons, and that's the buoyant force of the water. The buoyant force is equal to the weight of the water displaced. So this is the weight of the water displaced, and that will be 50 newtons. Let's find out what volume of water is displaced. That will tell us the volume of the object, because they have to be the same. The volume of the object is the volume of the water it displaces, and vice versa. So we know the density, we're talking about the water here, is the mass per unit volume. So if I would like to find the volume, I take the mass and divide it by the density. The mass would be 50 newtons divided by G over the density, which is 1,000 kilograms per cubic meter. This yields, for the volume of the water, to be 5.10 times 10 to the minus 3 cubic meters. This must also be the volume of the object itself. So the object itself weighs 315 newtons. If I divide that by 9.8 meters per second squared, G, then I have the mass of the object. If I then divide it by the volume, which we just discovered to be 5.1 times 10 to the minus 3 cubic meters, I have the density of the object, which is 6,300 kilograms per cubic meter. Now let's look at the second part of the problem. We're asked to find the density of the oil. Well, the weight of the oil displaced is 315 newtons minus 269 newtons equal 46 newtons. So this is the weight of the oil that's displaced. The mass of the oil then would be 46 newtons divided by G. That would tell me the mass of the oil. The volume of the object hasn't changed. So the volume of oil that's displaced is the same as the volume we encountered before, which is 5.1 times 10 to the minus 3 cubic meters. Therefore, the density of the oil is 920 kilograms per cubic meter.